a fraction that equals another fraction, what is our first step? So that would be 6 times a minus 6 equals 8 times a minus 1. Or vice versa, how you wrote it doesn't really matter. Distribute, so we have 6a minus 36 equals 8a minus 8. Move your variable to one side or the other, doesn't matter which one. So let's say I subtract 6a and add 8. And then divide both sides by 2, a would become negative 8. Questions on that one? And then 4 on the back. We needed to evaluate, so put 9 in for x. So this will be 2 times the cube root of negative 1 plus 9. Do what's on the inside first. So 2 times the cube root of 8. Then in your calculator, if you hit math 4, you would get your cube root. You could put 8 in it, and you would get 2. And then multiply to get 4. What's the final answer? Do you have a question?
Yes, are we going to learn how to do cube roots and that stuff later on?
Later on. That's by hand. Alright. Other questions on that? And then number 5, we needed to distribute. If you distributed and simplified, that's fine. I'm going to multiply as is. So we have 5 fourths x plus 16 twelfths minus 6 twelfths x minus 2 6 equals negative 5. If you didn't do this part, it's okay. If you don't write the next part, that's fine. So simplifying, we have 5 fourths x plus 4 thirds minus 1/2 x minus 1/3. Right? If you combined it like terms in the calculator, that was fine, or you could do it by hand. So this, you would have to multiply both parts by 2, so this would become 2 over 4. So for subtracting, this would be 3 fourths x. Subtracting these two, we get plus 3 over 3, which is really just 1. Subtract 1 on both sides. And then to get rid of the 3/4, take it, flip it, and multiply it on both sides. So this would be negative 24 divided by 3, or negative 8. Questions on that one? Make sure your names are on your answer sheet and pass that up. Okay. This is the writing linear equations part 1 that was due on Friday. As promised, you guys got a 68.2 as a class, so you get at least 1 gumball. And then for part 2, super close, but we did not get the 50. So you guys get 1 gumball, but not 2 today. Oh, it's still on my desk. Please be careful because this has been dropped and broken multiple times. But if you would like a gumball, you can go grab one. Please. And I want you to write them down. Oh. So definitions for parallel lines, and this should be very familiar to or similar to the investigation that you already did. Or should have done last class when I was not here. For parallel lines, they are lines that never intersect. Algebraically, you know 2 lines are parallel if they have the same slope. I'm going to add something. And different y-intercepts. Because because they need both. In geometry, you'll see a symbol that looks like this. This would be parallel lines, so if you want to start writing that instead of the word parallel, that's fine. Perpendicular lines are lines that intersect at a 90-degree angle, or that make a T, not an X, but a T. They have negative or opposite reciprocal slopes. So if you watched the video from last class, we basically said those words, but it's called a negative reciprocal. And then negative reciprocals are fractions that are flipped and the sign is switched. I want to go through these negative reciprocals and then you guys can back up. If anyone is still writing, I will come back to this after lunch. For these, what would the negative reciprocal of 3/4 be? Negative 4 over 3. What about 2? So it would be negative, but it would be negative 1/2. Negative 7/8. Negative 8. So it would have to be positive 8 over 7. 1. Negative 1. Now this last one is a little tricky and it will trick you up every time. There's a 0 over 1, so if I flip it and I have negative 0 over 1, that is
negative 1 over 0, which is just undefined.
Okay, so make sure you have those, and then you can write that last one. 0 and undefined will always be negative reciprocals, even if they don't look like it. So you have to remember that they are and will always be perpendicular. There are a couple different ways you have to be able to determine if something is parallel, perpendicular, or neither. One is by if you're given points, and then we find the slope. So let's do that for some of these. So as a reminder, to find your slope, that is your y2 minus y1 over x2 minus x1. So I'm going to label these. You can if you so choose to. And then find the slope of line AB. Where's the line segment AB? So this would be 6. Actually, let me do this. 6 minus 3 over 2 minus a negative 2. What would our slope be? 3/4. And then we're going to do the same thing for CD. So this would be 3 minus 0 over 3 minus a negative 1. Also 3/4. So looking at our two slopes, are these parallel, perpendicular, or neither?
Perpendicular.
Parallel, because they're exactly the same. Remember, this is your symbol for parallel, so you can either write the symbol or write out the word parallel.
I don't know how to spell parallel. Is it double L-E-L?
I think it's right.
It's right here. It is double L-E-L.
Questions on that one before we continue? Alright. Let's try number 2. Same process. Find the slope of AB. We have 4 minus 2 over 5 minus 0. Which would give us 2. Then find the slope of CD. So 3 3 minus 8 over 3 minus 1. Negative 5 over 2. So would these slopes be parallel, perpendicular, or neither?
Like, perpendicular.
Correct. Jackson, I should write this one. Okay. Questions on this process so far? This is just a piece of it. Great, we're going to do 2 more of these, one on this page, one on the next page. So, slope of AB here, 6 minus 8 over 2 minus negative 1. Negative 2/3. And then slope of CD, 3 minus 2 over 3 minus a negative 1. 1/4. So these are not parallel, they're not perpendicular, these would be neither, neither. You have to write out that word. Now, I'm going to give you some other neither, neither cases. If the numbers are the same, but one is negative, so like if I had negative 2/3 and positive 2/3, those are not parallel because one's negative. They're not perpendicular either because one is flipped. So that would be a neither, neither case. So be careful with those because those will come up and trip you up. Go on to the next page. We are going to do number 5. Okay, so same process. Find the slope. We have 7 minus a negative 2 over 0 minus 0. So hold that thought for just a second. It is undefined, but hold on for a second. And then negative 5 minus negative 5 over 6 minus 3. But for now, I'm just going to put 0 over 3. We already know that 1 is 0, 1 is undefined. But if you forget that piece and just stop here, right now, without knowing the 0 and undefined, what would you say these are? They are perpendicular, but looking at these, they're not the same. There don't seem to be negative versions of each other, negative reciprocals of each other. So you might say neither if you don't continue. I did that backwards, okay. So if you don't keep simplifying to say this is 0, this is undefined, you may put neither instead of perpendicular, which it is. So be careful with problems like that. So also, no, I'm going to grab the other one. Here, the x values are the same. So this is some x equation. The second one, the y values were the same. So this is some y equation. And those two have opposite negative reciprocal slopes. Would cross at a t, all those things. The next part, we're going to skip to number 9, is being able to recognize are these parallel, perpendicular, or neither by equation. So looking at these equations, would these be parallel, perpendicular, or neither? I heard different answers. So parallel, because the slopes are the same and the y-intercepts are different. These are parallel. What about number 10? How do we know?
Because they switched.
Correct. All of those things. So they've been switched or flipped. There are reciprocals, and one is negative, one is positive. All of this will be yes.
But I don't know if it's neither.
If it doesn't fit one of these two. So if they're not the same, and they're not perpendicular, either. Or if they're completely two different numbers, either. Alright, so like 11, those would be either. Because they have the same numbers, but one is negative, so it's not parallel. One is negative, one is positive, but one isn't flipped, so it can't be perpendicular, so this one is either. Neither.
Does it matter?
I just say both. Right. Then there are some that you need to solve to figure out. So how would I solve this, get this back in y equals mx plus b? Have x on both sides. And divide by 6 to everything. Y equals negative 1/6x plus 5. Then for the second one, divide by 3. Sometimes your equations will be at different stages. So y equals 6x minus 2. Are these parallel, perpendicular, or neither? We have one's negative, one's positive, and this is the flip version, so this is perpendicular. Number 15. Parallel, perpendicular, neither. Perpendicular, because even though this is similar to 11, 1 over 1 is just 1, and negative 1 over 1 is just negative 1. So they are negative reciprocals of each other. 16, you have to know the slopes. What would the slope of a y equals equation be? Zero. And then the slope of an x equals undefined. So if we have a 0 and an undefined, these are parallel, perpendicular, or neither?
No. Neither.
Perpendicular. 0 and undefined will always be perpendicular. If you're not sure, you could graph these. You can graph these off to the side. You could do so if you want. So the y equals 6 would be somewhere up here. And then the x equals negative 1 would be somewhere over here. And they're crossing and making that T. They are perpendicular. Are there any others on this page we want to see you go over before we go on? Yes. I'm not going to open that. You can go ahead. Okay, so not the page that says parallel, perpendicular, or neither, but the page after that. Not only do we have to, you have to know how to determine whether equations, slopes are parallel, perpendicular, or neither, but you also have to do this piece. So I'm going to explain this first before I read this off. You're going to be given an equation and a point. And this is going to be very similar to when we were writing equations through a point and a slope, or 2 points. But we'll be given an equation, we'll be given a point, and we have to come up with another equation that is parallel or perpendicular to the original one that goes through that point. So, that's what this is really saying. So we have to keep in mind that parallel lines have the same slope. Perpendicular lines have negative reciprocal slopes. And when we do this, we also have to remember the same equation we were using to write equations which I'll write that off to the side. Our y minus y1 equals m times x minus x1. So, in this example, we're given some equation. It tells us it's going to be parallel, our new equation, and it goes through this one. Cross out the y-intercept of this. You don't need it. It will just confuse you. Then, if our new equation is going to be parallel to this line, what would that slope be? Negative 4. So for this, you don't necessarily have to write the m equals. You could point to this and say that's your m. But you need to know what your slope is going to be. So now you have your m, you have your x1, y1, and we're going to put it into the format. So y minus y1, so 7, equals our slope, negative 4, times x minus a negative 2, or you could just change that to plus. So if you write out x minus negative 2, you have to then change it to a plus. If you want to change it to a plus first, that's also fine. And then how do we start solving this? So y minus 7 equals negative 4x minus 8. Add the 7 so that our new equation is 1. So now, if I'm comparing ours to the original, they have the same slope and different y-intercepts, so it is parallel to the original. Do you have any questions so far? This one is probably the easiest one. It just gets a little harder with each one. Okay. So now in number 2, same process, except this equation is not in slope-intercept form, so we have to change that first. Subtract x, divide everything by negative 3, y equals positive 1/3 x minus 3. This is not the answer to the problem. We just rewrote the equation that was already there. So now that we know our original equation, you can cross out that y-intercept, we don't need it. Our new line is going to be parallel to this one, so the slope will be 1/3. I'm just going to write that underneath. It's supposed to be an arrow. Yes.
When you're writing the equation y minus y1, when it's in the parentheses, like for the y equals negative 1, do we change that to positive as well?
Yes. So just like we did here, instead of putting y minus negative 1, you could just put plus. So y plus 1 equals 1/3 times x minus 3. Distribute. So y plus 1 equals 1/3 x minus 1. And then subtract 1. So y equals 1/3 x minus 2 would be the equation that is parallel to the original that goes through this point. Any questions on that one? Now we're going to do the perpendicular ones, which are very similar in process, but also a little different. Because we have our original equation, we have our point, this one is going to be perpendicular, so what would our new slope be? I'm also going to cross out the y-intercept. Negative 1/2. So we have to change that first before anything else. Otherwise, you're going to put in the wrong slope into your equation, and get a wrong y-intercept, so get the wrong equation. So this is going to be y minus 3 equals negative 1/2 times x minus 4. And then distribute and solve. Negative 1/2 x plus 2. Add 3 to both sides. What is our new equation? So compared to the original, the slope is the negative reciprocal, the y-intercepts don't matter, and it goes through that point. Soon, I'm going to show you how to do this in Desmos. Do you have any questions about that process? Yes. So if this has to be perpendicular, we have to take this, flip it, and make it negative. Right? This is like the most challenging because it combines what we did in 2 and what we did in 3. So we have to first solve this equation. Subtract 5x. 3y equals negative 5x minus 21. Divide everything by 3. So that y equals negative 5/3 x minus 7. Again, that is not the answer to our problem. We just rewrote. Now, we have to find the slope that would be perpendicular to the one we just found, which would be positive 3/5. And I'm going to cross out this y-intercept. Then we're going to use that slope and our point slope formula. So y minus 1 equals 3/5 times x plus 5. So we have y minus 1 equals 3/5 x plus 3. Add 1 to both sides. What is our final equation? Any questions about that? Look on the back. Are there any we want to see you go over and have questions on the back of that page, I should say? Someone else with more practice. 6.
That was a really bad sneeze.
You sure it was a sneeze?
Well, plus doing
I tried to get this started.
You made it worse.
I know, that's what I did.
it will cause
Liquid.
No.
Are there any others on that page? 8. These I'm actually going to show you how to do in Desmos. So everyone go grab an iPad.
Nope.
That's you, guys. Thank you, guys. Appreciate it.
Well, just me, because I'm nice to you. I'm not getting that.
I don't care.
Okay, make sure you guys are in Desmos. I'm in Desmos.
I think it's worse than
So, in order to do 6 in Desmos, we're going to put in the 0.83. Label it if you so choose. Then you're going to type in that equation that's given.
Say label.
Equals negative 4 1/4 x. What did you say? Sorry. You put it in the label. You and you want. Then in the next line, you're going to type in y equals mx plus b. It's very much like what we did before with the sliders, yes.
Y equals mx plus b.
Add the sliders at all.
Wait, I don't know how to do that.
So it should pop up.
Oh, I see.
Now, if we need an equation that is parallel, what would our slope be?
1/4.
Negative 1/4. So change your m to negative 1/4. And then we're going to move our b slider until it goes through that point 8-3. Oh, so close.
5.
Yes.
You could slide it.
Stop moving.
All of this stuff is on the page.
What? I know.
I have them.
Stevie. She's not paying attention.
So you don't care.
Not paying attention to that.
She's not paying
Do
attention.
we have questions on how that works?
So do we just write the equation? So it would be like y equals negative 1/4 x plus 5.
Yes. So now, right here, for this practice, you can just write it and say use Desmos. You're not using Desmos on the test. But this is good practice to know how to do it on Desmos.
You don't even need this. It's really just going to you know it's parallel. You have the same. Just have the same slope and it's an integer.
It's not, for the y-intercept, it's not any. It has to be a specific one that would make this go through that.
Oh, it has to be 8-3. Okay.
Right? 8 works the same way. So now I'm going to change all the things to 8. Number 8 on your paper. So the point is now negative 6, 7. The equation, I'm just going to type in as is. 5x plus 2y.
Hey.
Sorry, guys. My doesn't want me.
My chest is constricted. Let's
Change.
Oh yeah, I'm bringing
Alright, so we have our point.
Already bored.
If this one is parallel, we have to count the slope of this line. So it looks like if it goes through this point, it goes through this point, it's going down 5 into the right 2. So the slope of this would be negative 5 over 2. So change your m to be that. Not what I just did. And then move your b until it goes through that point. For the SOL.
So if we have to use Desmos for this, well, why can't we use it with T10?
This is an advanced class. And you need to know how to use the calculator for geometry.
But like, I don't want to take
What's the
geometry.
grade that you have to get to not take the SOL again?
So everyone in this class has to take the SOL.
Okay.
Unless you took it in this class as an 8th grader.
That's not on my kid.
Everyone's taking the SOL.
I don't think any of us took it.
Desmos is my new enemy. It's my earth side.
Alright, so our equation would be y equals negative 5 halves x minus 8.
Oh, here.
So negative 5
Oh, right.
Pick one of the perpendicular ones so I can show you how that works and then
9.
Okay.
Well, that was quick. I was going to say 9 too, no, so that's okay.
Alright, so change your point to 3, negative 3.
I love the negative 3.
Change the equation to the one given. then if our new line has to be perpendicular, what would the slope be? Negative 4 over 3. So go ahead and change that to negative 4 over 3.
Oh.
And then move your B until it goes through that point. So if you look at these two lines, you can see that they cross, they make a T. It looks like an X, but if you look at it sideways, it is a T.
Oh, there it is. Wait.
Okay. So the equation would be y equals negative 4/3 x plus 1.
That's why. No, that's not why.
Okay, I'm going to give you 2 problems to try, and then you're going to have me check it. You can work together on these 2 problems, but you do need to have me check them. Afterwards, you can either work on Delta Math, you can work on more problems in these notes, or did the sub pass out the activity from last time?
Yeah.
So not the investigation, but an activity with little cars.
No.
Okay, so if you want to do that, after you get those 2 checks, then you can do that, if there's time.
Luke doesn't have this week. It's like Thanksgiving week.
You guys have 1 due tomorrow on parallel and perpendicular
Oh, I
lines.
did that.
I might have already done that.
That's great. So I want you to do number 5 and 12.
Run away. Okay, it's going back.
Actually, no, I mean
Just show it to you after we plot